In this video we're going to look at drawing a tangent between two circles. This is going to be an internal tangent, and an internal tangent is a tangent that passes in the space in between two circles. So I've got one circle here, another one here, and my tangent is the line that passes in between them. If we were to say that there were external tangents, there would be lines that would be going either down here or up here. So for this video, again, just like we did for the external tangents, we cannot draw a tangent between two circles. What we can draw is a tangent between a point and a circle. So if I have a line here and I need to reduce one of these down to a point, it makes more sense to reduce the smaller one, but you can do this one here also. So if I'm going to reduce this one down by the size of the radius s, and my tangent is going to be here somewhere, then this one is going to have to get bigger to compensate. So just like when we had external, our lines, this circle gets smaller, the other circle has to get smaller by the same amount. Here it's going to be the opposite. As it's internal, our tangent, our circles, this one will have to reduce in size, and this one will have to get larger to compensate for it. So what we're going to do is I'm going to take the radius of the small circle, radius s, and I'm going to add this radius onto the radius of this one here. So now when I draw a circle, it has a radius of r plus s. So what I'm going to do now is I'm going to draw a tangent from a circle from this point to this circle up here. So to do that, we need to join our centers, or join the point to the center, bisect the radius, or the line, and that gives me this point here. So what I'm going to do next is if I take this point and I swing this out to touch my radius, my circle up there, this point here joining back would be a point, would give me a tangent. So what I need to do now is I'm going to join this point back to the center. So what would be the point of contact back to the center, and that gives me what would be the point of contact between the large circle R and the tangent that was to join off over here. So if my tangent is going perpendicular to that, if we follow it across, it's going to come and touch it over here. The second normal for the second circle will be parallel to the first one. So this brought down along this way, this gives me my other point of contact. Now all I need to do is join these 2 points up. There we have it, a tangent drawn between two circles, between this circle, and both points of contact found. So quick recap on what we did. Took the small circle and reduced that down to a point, and in doing that had to increase the size of the other one by the same amount as the radius of the small one. So this radius here is plus s, adding on to it. I draw my tangent as I would normally from a point to the large circle. So by bisecting and swinging my arc, it cuts the outer circle. That gives me a point on where would be a tangent joining from here back to the center. But now what I'm going to do is I'm going to join this point back to the center of the circle, and where it crosses my original large circle gives me the point of contact. This point of contact, this line here, is a normal coming off it. It's perpendicular to the tangent, which means it's going to be parallel, coming from the other circle, coming from the center, giving me the other point of contact. If I have both points of contact, I can now draw a straight line tangent joining the two.